Alright, so today we're talking about how to take the derivative of an inverse function. So before we take the derivative of an inverse function, we need to remember what an inverse function is. And it's really like a pulling back type function. And so the definition is that if k is a value in the range of a function f, then f inverse of k is the set of all x values for which k is equal to f of x. Now in Algebra 2 and Pre-Cal, we pretty much carefully avoided cases where it pulled back more than one thing, where the inverse wasn't an explicitly defined function. But, you know, in general, that's what the inverse does, is it takes in y's and it traces back to x's. So, you know, for the first example, you know, we've got data given to us in a table, and those of you that were in my Pre-Cal or Algebra 2 or whatever, we focused on this a lot. Pulling back from y to x. So when we see f inverse of 5, the first thing that we do is we say f of x equals 5, and we solve that equation. Now in this class, it's always going to pull back to just one number, okay, because it's just like a very specific thing that'll comprise a couple of questions on the test next time. Maybe it'll show up on the AP exam in May, maybe it won't, you know. From what I've heard, it's oftentimes one multiple choice question, you know, and it frequently appears as a data in the table, and I've got a lot of examples of these. There's plenty in your multiple choice practice set, plenty of it practice to be had. So what we do is we say f of x equals 5. Where does f of x equal 5? I see it right here. And we trace back to our x value, and that's x equals 4. So we say that f inverse of 5 is equal to 4. And then maybe we're given a graph. You know, we have to be able to work with the graph as well, and a table and algebraic. Okay, so suppose g is the piecewise linear function whose graph I drew just before class. And suppose h is g inverse. So we want to find h of 3 and h of 5. Okay, so really what this is, when they say h of 3, that's g inverse of 3. And h of 5 is g inverse of 5. When we see g inverse of 3, we say g of x equals 3. See g inverse of 5, we say g of x is equal to 5. Okay, so I'm going to start with 3. Really what this inverse function is it goes to a point here in the range, a y value, and it kind of scans side to side, and it sees, okay, I found a place where y equals 3, and it traces back to x equals 4. So I would say that h of 3 equals 4. Okay. Then we have g of x equals 5. Okay, but then I see it, you know, from here, I'm going to hit it twice, which is kind of an issue. Okay. This will probably be the only time you'll see that happen in this course, because for the AP Calculus items, there aren't two options. They stick with strictly one-to-one functions, which are the type of functions that have a well-defined inverse everywhere. And so this here, we're tracing back to x equals 2 and x equals 6. And I especially in Algebra 2, I tried to convince you that that was an okay thing to have happen. It wasn't a big deal. Just because g inverse isn't a function in the vertical line test sense of the word, doesn't mean it's not still an interesting thing to do. And so I could say that h of 5 is the set 2 and 6. Okay, but that won't happen again. Just reminding you of how inverse functions. Okay, the next thing, how to take the derivative of an inverse function. Well, if f and g are inverse functions, then we can say that f of g of x equals x and g of f of x equals x. Sometimes that's how they'll hint to you in the statement of a problem that they're actually talking about inverse functions. So we need to know that fact. And so the derivative of f inverse at x equals c is given by f inverse prime equals 1 over f prime of f inverse. Okay, and probably the best way to remember that is that f inverse is an x value. Really, when it comes down to what f and f inverse are, that's an x value. So 1 over f prime of f inverse. There's no negativity in it. Okay, the proof is really surprisingly not that complicated. What I'm going to do is I'm going to start off with the fact that f of g of x is equal to x. And then I'm going to take the derivative of both sides. So I'm going to say the derivative with respect to x of f of g of x is equal to the derivative with respect to x of x. Now we know that the derivative of x is 1. So, and we know what the derivative of f of g of x is. That's what we did last time, chain rule. So that's going to be f prime of g of x multiplied by g prime of x. So now what I'm going to do is I'm going to divide both sides by f prime of g of x. And so I'll have g prime of x equals 1 over f prime of g of x. But anybody see like where I'm going from here? Yes, okay. G is f inverse. So really what I have is f inverse prime of x, the derivative of f inverse at x is 1 over f prime of f inverse of x. So that was a nice short proof that we could fit in the amount of time that we have today. This was, oh, that was a graph that I was trying to overlay onto there, and then I just ended up sketching it back there. I forgot what was there. Right. Here's one, though, where they didn't give us a graph or a table. They gave it to us algebraically. Okay. So find g prime of 3. G is f inverse. So I want f inverse prime of 3. I'm going to write down the formula. You all know that the more times you write the formula down, the more likely you are to remember it when you really need it. Like 2 days from now when the test happens, semester exam, AP exam, times like that. F inverse prime of 3 is 1 over f prime of f inverse of 3. So the first step is to find f inverse of 3. And what we do when we take that is we're going to say f of x is equal to 3. Okay, so I've got 2x minus 3 equaling 9, 2x equaling 12, x equals 6. Remember that when we square both sides of an equation, we do need to check to make sure that we haven't done anything bad. So I'm going to just check that, and I've got 12 minus 3 is 9. I take square root of 9. That is equal to 3. All right, so x equals 6. Okay, so now it's 1 over f prime of 6. Okay. Now the thing is that I don't have f prime yet, so I need to write down a formula for f prime of x. So that's where I'm going to go over here, and I'm going to say f equals 2x plus 3 to the 1/2 power, so that f prime, I'm going to bring that 1/2 down, leave the inside the same, decrease the power by 1, and then also consider the chain rule, consider the derivative of the inside. Oh, it's 2x minus 3. That's well, thank you for saving me before it went too far. And then the derivative of the inside is 2, so there we have it. And then I'm going to say f prime of 6 is equal to 1/2 of 12 minus 3 is 9. 9 to the 1/2 is 3, so 3 to the negative 1 is 1/3. So that'll be equal to 1/3. Now, at last, we can say that this is 1 over 1/3. And that would be a safe place to stop if it was free response, right? But it's multiple choice. We need to know that that's the same as theirs. Okay, so most often what we're going to see is them give us just the right amount of data to solve this problem. And so they're telling me that f of 5 equals 2, f prime of 5 is negative half, and g is the inverse function of f. So find g prime of 2, which is like code for saying find f inverse prime of 2. Well, we know that the derivative of f inverse is 1 over f prime of f inverse. Okay, so first thing first, I need f inverse of 2. That's where f of x equals 2. Where does f of x equal to? Right there, where x equals 5. Okay, so that's x equals 5. So g prime of 2 is going to be equal to 1 over f prime of f inverse, which was 5. So this is equal to 1 divided by negative 1/2, which is negative 2. Okay, so why don't you all try that? See how it goes for you. So, this is kind of more columns than we need in this table. But oftentimes they are going to give you some kind of trick data that could lead you into making a mistake. And so really what you got to do is we got to find f inverse of 3. Okay, if they ask you to find f inverse of 3, they're always going to have x equals 3 as an option. And 1/4 would be probably answer choice A. Right? So what we do is we find it in the y column. Okay, we found 3, then we go back up into the x row. And then we take 1 divided by whatever we see in the derivative. Okay, so you'll kind of get used to that pattern of finding it in the y column, or y row, y column, however it's set up, tracing back to x, and then looking down at the derivative at that point. That's how we do that. Okay, so we've got our arc trig derivatives written down. We probably need to do a little bit of practice with those because we haven't spent much time with it. So find the derivative, right? Well, f of x is arc sine of 2x. So f prime of x, I know that with arc sine, I set up a fraction, it's 1 over the square root of 1 minus the inside square. That's 2x squared. And then we're going to multiply by the derivative of the inside. And this inside has its own derivative, which is 2. That wasn't too bad. Okay, here we have one with maybe more layers of chain. That's probably going to be good for us. Okay, so dy dx, I'm going to start with the outside with this 2 and bring it around the front, do the power rule. That's going to be 2 times arc tangent of 3x left to the first power. Now we're going to take the derivative of arc tangent of 3x. Okay, The derivative of arctangent u is 1 over 1 plus u squared, so it's going to be 1 plus 3x squared. And then we're going to multiply by the derivative of 3x, which is going to be 3. Okay. Okay, so last thing I got for you is one more of these data questions, the type of thing you would definitely be likely to see on a multiple choice question. So they're going to ask us to write an equation for the line tangent to the graph of y equals f inverse of x at the point where x equals 2. Okay, so what we need is we need a point. And so that's going to be 2 and f inverse of 2. Okay, well, f inverse of 2, we set f of x equals 2. And I see that right here. Okay, that's x equals 6. So that's going to be 2, 6. The slope will be f inverse prime of 2, okay, which is 1 over f prime of f inverse. F inverse was 6 right there. So that's 1 over f prime of 6. From the data in the table, we see that's 1 over negative 3. And so with a point and a slope, we're ready to write the equation. And that would be y minus 6 is equal to negative 1/3 of x minus 2.